Okay, we're going to look at and round up what we consider the functions of bone. You make sure in every system we look at its functions. Because clinically, if you have some sort of patient that has an issue with any system, you say, oh, let me go to the functions and let's say, what is it that they can't do anymore? All right, so that's very important, understanding the functions of and rounding up with your understanding of any system. Make sure you understand what functions they have. All right, for the bone, you have your 6 functions, and the first 3 that we'll talk about make sense. The first 3 are related to how this material is like brick. All right, and so that hard-like material like brick, which is bone, will be a structural framework, will support other actual tissues, will support other different organs, will be a place of attachment. It could serve as a lever. It's so hard, it could serve as a lever for muscles to attach to. So that's a structural framework. So obviously that makes sense. And also a protector. This hard-like material, if it happens to cover an organ, that organ that's very delicate is now protected. It won't be harmed because your actual bone is protecting it, such as the parietal bone, for instance, covering the actual brain. And also to assist with movement, not produce movement. That's muscles that produce movement, but to actually be the actual lever that the muscles attach to so that the muscle can move something. Something has to be moved. It's the skeletal bones, the skeletal system. And so that assists with movement. Movement's not complete if the muscle is not attached to something and can move something. So it assists with movement. The other 3 that I'll talk about, well, you wouldn't have thought that was related to bone. But yes, your next function, which is mineral reservoir. The term reservoir indicates that it's a storage place. So yes, you have all of this calcium in bone, which makes bone very, very hard, which makes bone brick-like material. So that's necessary for it to do that. However, it's so much in there, it's so much to spare. There's a lot of calcium to what? Spare. And that's why it's a place where other tissues in the body can rely upon that bone to get their calcium source. Obviously, the main mineral in bone is calcium. So that's a place where other parts of the body can get their calcium. All right, so it's a place where calcium's stored. All right, and so we already went into in lecture, we talked about calcium homeostasis for what type of things? For your neurons. Neurons cannot function without calcium, as we'll see in our next chapter. Also what? Muscle cells. Muscle cells cannot function without calcium. Again, as we'll see in our muscle chapter as well. All right. And another feature is platelets. These special cells that are a part of what we call blood. Platelets are the glue of blood, and they will not function without calcium. So calcium is very, very important. That is huge. The fact that your muscles or your nerves can't work without calcium, that is very important then that your actual calcium is available to all of these different tissues. And that means it has to be a certain amount of it in the blood. All right, because the blood is the distributing, if you will, tissue. It's the distributing fluid that distributes everything to all the different things in your body, all the different tissues in your body, like neurons and muscles. And so therefore, you're gonna have to have a certain amount of calcium in the blood. And where does that calcium come from? Well, the reservoir, right? And that reservoir happens to be the bone itself. All right, who's going to get the calcium out? Well, we talked about that too. It's going to be your actual osteoclast. Okay, they constantly do what? Eat up this bone matrix. And how do they eat it? They actually dissolve it, right? So they actually use, well, 2 things have to be dissolved, doesn't it? It has to be the osteoid component, which is just the protein, fibers, and ground substance. And then the actual mineral component, which is most of it, which is calcium. And so, yes, he uses 2 things to dissolve both those things. And that would be for the for the actual osteoid component, which is most of the protein there, the organic component, if you will, that is actually a proteolytic enzymes that it secretes. And now it breaks up all those proteins, right? Now he can eat it. To actually get that calcium and dislodge it from this brick-like material that calcium creates, basically, he uses hydrochloric acid. So osteoclasts secrete what we consider hydrochloric acid. And now it what? It actually dislodges the calcium from this material, which we call bone matrix. And now he can actually ingest that. So this phagocyte, this actual eating cell, is now going to be able to, if you will, take in this material after he uses his proteolytic enzymes, hydrochloric acid, and now he gets the actual calcium into him. What's going to be on his other side, like I said in class, is going to be blood vessels. So as soon as he ingests all that calcium, where does it go? Goes right outside of him it came into him by way of endocytosis, goes through him by way of transcytosis, and now it comes back out of him into blood vessels by way of exocytosis. All right, a term we've come across many times now, exocytosis. And now all of that calcium goes into the blood. And that's how it works. So calcium getting into blood is determined by the activity of that bone cell called osteoclast. All right, so osteoclast activity determines how much calcium ends up in blood. All right, so, but which function of bone heavily relies upon, if you will, that feature of calcium getting into blood? Mineral reservoir. This osteoclast is taking calcium from bone that bone has to spare. So you would think, oh, that's a bad thing if a whole bunch of calcium's leaving bone and going in the blood. Because, you still need calcium for what? For it to be a brick-like material, to be a structural framework, for being a protector and assist with movement. All right, but it's so much calcium in bone that it's some to spare. And so there's some calcium that's stored. So that calcium that the actual osteoclasts are gobbling up is some calcium bone doesn't need, all right? And that's going to be some calcium for other cells in the body, such as your neurons and your muscle cells and platelets, all right? Platelets, the glue of the blood so that you don't bleed to death, all right? So that's the beautiful story here as it relates to how calcium ends up at the right level in blood so that your neurons, muscle cells, and platelets can have their fair share of calcium, okay? All right, very good. And that, like I said in class, has to be at that 10 milligrams there. Obviously, if your calcium's low, called hypocalcemia, then there is going to be a hormone that is secreted. That is going to be the actual parathyroid hormone. He comes from the parathyroid gland that has receptors on him, detects this hypocalcemia. And then that parathyroid gland serves to be the control center, secreting that parathyroid hormone, which is going to be a messenger, that's going to go through the blood, all through the blood, and go to the effector cell, which happens to be the osteoclast, and do what to this effector cell? Increase its activity. So what parathyroid hormone does is increases the activity of osteoclast, which makes sense, right? He came out in the first place. Parathyroid hormone comes into the blood in the first place because there is a low amount of calcium in the blood. All right, so what does he want to do? He wants to make sure that you increase the amount of calcium in blood, okay? So it just makes sense what I'm saying there, okay? The hormone involved with making sure you get more calcium in blood is the parathyroid hormone, okay? And through that process that I described, which we're always going to use, we're always going to talk about homeostasis, okay? That's the process, homeostasis. The process of it being a stimulus, hypocalcemia, a low amount of calcium in blood. Then that's the change in that internal environment. Environment has to be the right amount of values for everything, even calcium levels. And so who's going to detect that? Receptors. The receptors on that parathyroid gland pick up that it's low calcium. That information is dealt with at that same gland, parathyroid gland, which is now the control center, Control center makes a decision, says, what do I have to do? Secrete parathyroid hormone. All right, that messenger now goes throughout the whole body, but then goes to that effector cell. That effector cell, that's in homeostasis. That effector cell, that is the osteoclast. And what does the parathyroid hormone do to it? Increases its activity. If you increase activity of osteoclast, it eats more, and now all of that calcium is going to go into the blood. Okay? And what is that? That's the response. The end of an actual homeostatic process is a response, which is to do what? Increase that calcium. Go against, oppose the stimulus that originally started the whole process. All right? So that makes sense. And that's a negative feedback process. When the